was looking around my house to find objects that had been either enlarged or reduced to produce similar figures, and I recognized that the circles on my stove were in fact reduced or enlarged versions of each other, and therefore could be examples of dilations. So if I were to start with the circles in the back and multiply them by some number, I would get the circles in the front. The number that I multiply the small ones by to get the large ones are called my scale factor and represented by the letter K. That number, to enlarge it, has to be greater than 1. If I were to start with the larger circles in the front and I were to multiply them by a scale factor between 0 and 1, I would be reducing those circles, and to get the circles in the back. The circles on the stove are all similar figures of each other, as are all dilations. If I start with an object and I dilate it by either enlarging it by a scale factor greater than 1 or reducing it by a scale factor between 0 and 1, I am creating similar figures of the object that I started with. When you dilate a figure, you are either enlarging or reducing that figure. So whether it's a line or a shape, you're going to enlarge it or reduce it based on the scale factor, which is represented by the letter K. So in this case, we are taking line segment LA, where the original point L is 1, 2, and the original point A is 3, 4, and we are enlarging it by a scale factor of 2. I know it's enlarging because when a K factor is greater than 1, when the scale factor is greater than 1, you are basically enlarging it. And when the scale factor is between 0 and 1, or a fraction, you're going to be reducing it. And like the top formula says, if this was written in notation, you would have a dilation of scale factor 2 is being applied to the point or the points x, y, and to get the new image, you're just going to multiply each coordinate by the scale factor. So in this case, when I have L, which has an x of 1, an x coordinate of 1, I'm going to take 1 and I'm going to multiply it by the scale factor of 2, so I'm going to get 2. Then I'm going to take L's y value of 2 and multiply it by 2, so I'm going to get 4. So when I go to draw L prime is going to be at 2, 4. And then when I go to A prime, I know that the x value is 3, so when I multiply 3 by 2, I get 6. And the y value is 4, so I'm going to multiply that by 2, and I'm going to get 8. And then I'm going to plot 6, 8, which is going to be somewhere up here. And so my line segment is going to be twice as long as the original LA. So LA and L prime, A prime are going to be similar to each other, and the scale factor that one is going to be compared to the other, the ratio of L prime, A prime to LA is going to be 2 to 1. So again, just like the last slide, when you have an original point with x and y coordinates, you are going to multiply both the x coordinate and the y coordinate by whatever the scale factor or the factor of dilation is. So in this case, I have chosen 1/2 to show you what happens when you have a scale factor that's a fraction. The original point M has an x value of -2 and a y value of 4. So I would multiply -2 by 1/2 and I would get -1. I would multiply 4 by 1/2 and get 2. So M prime would be -1, 2. And A prime would be 1/2 of -4, because A has an x value of -4. So A prime's x value would be -2, and A prime's y value would be -1, because -2 times 1/2 is -1. And so if I connected it, M prime, A prime should be 1/2 of MA. So just remember that whatever you're given as your scale factor, you just have to multiply both the x coordinate and the y coordinate by that scale factor to get the coordinates of your your imaged point. We are only dilating with reference to the origin, so this method works when you are dilating with reference to the origin.